Okay, so thank you very much for coming, and you have already won the first lottery, apparently, to be the ones who have been let in here. They should, of course, have given me the good big room. They should have known that. So I'm happy that all of you have taken the time to come here, because we're going to talk about something that's very close to my heart, which is what...
Stop. Stop.
So the talk I'm going to give today is it's going to be about the QObject, of course, and what that means and how it's done. But what I'll try and do while doing that is to give you an idea of how you should think about Qt code, instead of just going through, yeah, this is what it does. I will to some extent have to do that in this talk, but I will also try and influence your way of thinking, the way you think about Qt code, the way you think about your architecture, how this should be affected by what the QObject technology gives us. This is my goal. That's this high up when I started by saying out that this is actually a fairly, this is not an advanced talk that I'll give here, but my goal for what I'm going to do to you is very, very high. I'm going to change the way you think. That's, well, we'll see in 10 years if I succeeded or not, but I'll try. So, some of you noticed there is a small black box down there. At the end of Nassar's talk, Nassar Babik, this afternoon, we will have a small competition where we will draw between all the business cards we got. We have a small drone. It's really small, but it has a C++ API, and it is a lot of fun to hack this small little baby. So if you want to win this one, just throw your business card over there. If you didn't bring a business card, just fill out one of those we have there. We do have fill out your own business cards, and then we'll draw it. If you're not at the talk, then don't worry. We'll just ship it to you after the show. Another thing, those of you who are not in the back, can maybe see that at the bottom I have a blue line of text that is a random pun joke, and that's just something I do. Those of you who attended one of my 2 talks yesterday will know that's the way it is. There's no reason for it, other than my slides are incredibly boring, so you'll just look at that and hopefully laugh a bit. Whatever. So, my name is Thorsen. I have started a company called Viking Software about 3 years ago, but I first started out with Qt coding all the way back in 1997, March 1997, when one of my friends showed me KDE at the time, and I was like, woo, I need to do this. And then that was also the first time I started coding C++ for the reason of Qt. So since then, I have been programming Qt in all different kinds of jobs and companies and so on. And I'm still doing it. Even though I run the company now, I'm still trying to do some programming at least. Viking Software is a consulting company. We help guys like you implement the applications of your companies. And that's all we do. We don't have a product, so we're not competitors. We just help out guys like you. Okay. Let's get on with it. This slide could be called 2 things. It could be called the agenda, and it could be what is the QObject technology, because it sort of serves the same purposes. I assume some of you saw the talk that Simon Hausmann did yesterday about signals and slots, and some of what I'll say today covers some of the same topics that he did. He went into a lot of detail about exactly signals and slots, and I'm not going to go into that much detail, because that was 20 minutes, or actually 30 minutes, just by signals and slots, and I don't have 3 hours, so I can't do all of this in that level of details. Instead, I'll talk more about why the signals and slots work this way, what is the relationship with that and the properties and the introspection and so on, and how does it all fit together in QObject? What's the idea of this? And of course, I'm sorry to have to say that apparently Herb Sutter's talk about 2 hours ago or an hour ago made this irrelevant, because he's going to change the Qt world. But We'll see. And oh, it's great news to finally be able to say, I actually like mock, because Herb Sauter says it's a good thing, so now we can proudly say it as well. Perfect. So let's talk about QObject itself, the class, and the subclasses that it has. It's, of course, the base class of a lot of the classes we have in Qt itself, and a lot of the classes we write as Qt developers. When I say Qt developer, I don't mean a developer who works on Qt itself. I mean a developer who works on Qt application code, usually. But it's actually sort of the same, so who cares? So what is it that makes up a QObject thing? Well, there are the obvious things. You can't copy a QObject. Some of you will try to do it. I have seen a lot of attempts. Don't. It fails. And there are a lot of reasons for that. First of all, the biggest reason is the parent-child relationship. And if you don't really know, if you want to dispute that this is the reason, then come along. I do have the black belt in Taekwondo, so we can talk about it. I also run a company called Viking Software, so I have access, and careful. But just get over the fact you cannot copy a QObject. And I've seen in so many customer codes that it's attempted not to do it. No, if you need something that you copy, then you have a value class. All the value classes in Qt do not subclass QObject. And that's for that reason, because a value class, that's usually something you want to copy. And a QObject, you cannot copy. A QObject is something that sits in an object tree, usually. There are free-floating objects, but not a lot of them. So at the last there, I write add 40 bytes because the reason I do it, and it might be 50 today, who cares? It's not a lot. I hear that a lot from people who are used to writing low-level C, and now their boss has said, you gotta go to C++. And they say, yeah, but that's ineffective. We have these subclassing, and then QObject, it's a big blob, and it's 40 bytes, maybe 50, even if it gets to 60. Who cares? It doesn't mean anything, performance-wise or memory-wise or so on. Doing something that's a subclass of QObject does not come at a real cost. So just do it if you want to. Yeah, so the first one, the thing that Simon talked about yesterday, he showed you the emit definition of what emit does. So you have some signal that's connected to a slot somewhere, and when you emit the signal, you write emit signal name. And he showed you this definition here, that emit is empty. Why is it empty? He said that's just to make the code more readable. I disagree on that completely. Actually, it's one of the very few cases where I disagree with Simon because he's a really good guy. And you should normally listen, but not here. You should listen to me. The reason you do say emit is because you invert what we do when we call a function. And I'll tell you what that means. When you write a function call somewhere, you say, I now decide that I'm going to do that. That's not what you do when you emit a signal. When you emit a signal, you say, my state has changed. I don't care what happens when that happens. I see people nodding. You actually see the difference here. I told you I was going to change the way you think. So imagine a button, for example. When you click a button, if you, in the code, say, okay, I have a button. When a button is clicked, I will then call do stuff. Then I'm going to publicly whip you. Because a button should never do that. That's not its responsibility. A button should only say, hey, I was clicked. And then it's up to whatever instantiated the button. That's the case where you know what should that mean. What does the button do? What does the user mean when he presses his big finger down on the button? So the button doesn't have the responsibility, and it's one of my keywords when I talk about architecture, about C++. Who has the responsibility to do something? And that is what emit is to me. It is to say, I don't have the responsibility of what happens in this call. That's what emit means to me. So it's not just about making the code simpler to read. To some extent, he is right, because what this does is tell me that this is a signal. And for that reason, we can now see that I don't have the responsibility of what happens when this does. It also means other things. For example, that we don't know how long time this is going to take. If you call a function, you usually have some idea of what that means performance-wise. Not always, but a lot of the times we sort of know what it means. But when you emit a signal, everything in the world could be connected to that signal. So your entire application could halt and block for the next 3 hours. Not your problem. If that happens, that's another problem. It's not the class that emits the signal that does this. So that it's empty, the definition is empty, just means that it doesn't have any C++ meaning to write emit my signal. Okay, enough on that. So let's take the other ones. Define slots empty. Another one. That actually does have meaning, because that's what tells the mock that we are now in a slot. So we have to do all the magic that goes into the mock object, the code-generated object, so we can do all the dynamic calls and so on that we'll talk about in a minute. Not in a minute, a bit later. Define signals public, it says at the top. I think that's a mistake. It used to be, I don't know how long time ago it was, probably when the Greeks ruled the world or something, it used to be protected. And now think about what I said before, who has the responsibility of doing something? I don't think it's correct that anyone in the world should be able to say to the button, oh, you've been clicked. I think that's wrong. You can say it out there, say, emit button, emit, clicked. I have a problem with that on a fundamentalistic level, but I'm not going to go jihad on them or something like that. Just be careful about it. Don't emit stuff on other objects. You should emit stuff from inside the object itself. Ooh, I'm talking too much about this slide, apparently. So, the connect, I assume you've pretty much all done this. You have the sender, you have some method, you have a receiver, and you have a slot. Yeah, blah, blah. We know that. It can be direct or queued. Some of you at least saw what this means yesterday. Direct means that a signal slot connection is just a function call. It might be 1 to 0, doesn't call anything if you don't have anything connected to it. It could be 10,000, but it's actually a direct function call. Where if it's queued, then you put an object on the event queue, you wait, you process, queued, processes all the events, and at some point it gets to the object that says, now we have to handle this connection, the signal was emitted, call this function in that area. That could be in a separate thread, as Simon showed, but we'll see. There is a couple of examples here. The first one's very simple. We want to have a request, an HTTP request for a very interesting website that I'd chosen completely random. So you just call that's Q Network Access Manager, the QNAM. It's called QNAM when we talk about it, and it was big. So you connect to that, you say the finished, and then do stuff when your connection is, or your request is done. Now there is a reason I chose exactly this one, because I do want to have a trick on the next slide. Because when you do this, those of you who have tried and do a network request like that, you know what the problem is. The problem is you have to store the request you sent, and when the information comes back, then you have to find the original request and match those two. Fortunately, we have fixed that with C++, with lambdas. when I first saw lambdas, the very first time I saw it, and that is some years ago by now, this was the example that convinced me that lambdas are actually useful. And you're the one who told me, one of my employees. Yes, you're to blame for this slide. So this one means that I keep the context of what it was. So I don't have to do the matching of, oh, it was that request that now came back. That's fine if you only have one request, but if you have 100 of them, then you have to encapsulate this call somehow. And the simplest way to do that is simply to encapsulate and do this capture inside the Lambda. Then you immediately have this one. There is another good reason for doing this, which is that the place where you send the request is also the place in the code. So in our minds, we're in the same place when we write the request and the response code. So that means they're connected instead of being in two different places in the CPP file, or maybe even in different classes. So what you do here is several tricks in one. You get your mind in the state where we could talk about both the question and the response, plus you've put the two classes or objects together. Very nice thing. Do it. And there are other cases where this makes sense as well. For example, you could have the button in the place where you instantiate the button, then just connect to the click signal, and right below this, you write what the click means. So now you have connected the instantiation of your object, your button, with what actually happens when the user uses that. So, QObjects, properties. Properties is a thing that I struggled with for a while to see the point of. I assume some of you saw my QML talk yesterday, and I talked a bit about this area. Because writing this QProperty thing doesn't really do anything, well, not a lot. But if you're in QML land, that means you have access to this property. If you're using this on widgets, then it does mean something, because then you have access to the property inside QDesigner. So if you say, okay, this is the class I want to now, I make a QDesigner plugin, and I want to instantiate this widget, so then you can now access this property and set it. Yeah, Morten, you can walk around, you can throw the black box with business cards, they'll walk around you. He's got that covered. Okay, so now QProperty is again an empty definition. It doesn't mean anything, it doesn't do anything, it's just a marker for mock. That's the only thing it does. So it gives some information in the mock list of objects, and I'll show you exactly what that means later. The dynamic properties is something that is a slightly advanced topic. It means you can set anything. You have a QObject, any random QObject, your button, QApplication object, anything. You can call set property and then give it a name and any Q variant in it, and store that on a project or property. And this is not something you do a lot because it's basically bad, because we remove the type safety, we remove any information or indication that this is there, so you have to know that it's there. So it's not good coding style to use this a lot, but there are a few examples where it actually does make sense. So just know that it's there, and if you're suddenly stuck in a situation, then, ooh, I could use dynamic properties for this, then you're probably in the wrong direction, but at least it's possible. So, malmoc. It's a code generator. What does that mean? It means it looks at your header file, it outputs a CPP file. That's all it does. And where does it do it? Well, if you use QMake, and I actually do, I have to confess I'm one of the only people in the world who truly loves QMake. Am I among friends here, or do you hate me? I know some of you will like CMake or cubes. Really? Cubes? Okay. I have found the two who like cubes. Okay, so when you use QMake or cubes or CMake when you set the right flag, then it scans your header file and then it looks for the QObject macro and looks for this, and if it finds it, then it puts it on the list of source code that has to be mocked. So then it takes your header file, adds a CPP file, and you get some extra stuff, and we'll look at what that is. Now, this says here that it implements slots. That's obviously wrong. It should have said implements signals, because mock cannot know what a slot should do. When you have, okay, the button was clicked, now I need to do something about it. That's your decision. What happens in a slot stays in a slot. No, it should be whatever you decide that should happen when the action the user did or this came in from the network. The signal, on the other hand, that mock knows what happens. The only thing the signal does is just call the individual connected objects or push objects on the event queue if there are queued connections. So that's the only thing. That's why you don't implement a signal and you do implement a slot. Dynamic method invocation. That's not something you talk about a lot in C++. When I was in university in the 90s and we learned about Corba, and dynamic method invocation was the greatest thing on earth in Corba. So we could do this stuff. And sure, that's fine. You can call invoke on any method that is invocable in a QObject. So if you have a slot, for example, you can say, I want on this object to call the function that's named this with these arguments and store the return type here. It's not a lot we do that, but if you do write something like a RPC mechanism, for example, you send something over the net and it comes back with the message that this should now call this function. That's the message you get from the server. Call that function. And you blindly follow it, of course, because you know the server hasn't been hacked. So you will now call the C++ function. That's one of the cases where you would do something like this. Or if you read an XML file, if you're still stuck in the 15 years ago, or a JSON file today, and say, I should now call a function, then you can use this stuff for that. Okay, so let's go deep into the belly of the beast now. Now, stay quiet, I'll help you. This is what the QObject macro does. I cut out 3 lines because I don't have that much space here. And the 3 lines just does some locking and stuff. It's not important. These are the things that does something that matters to QObject, to us as Qt developers. Now, these things are not something you use yourself and consciously say, I now use these methods. That's usually not what you do. It's hidden inside the QObject macro for a reason, and that is, this is the stuff that makes things work. There is an exception to that, and that's the TR. So you should, of course, make all your code translatable. So sure, your user visible strings called TR, blah, and it uses that one. But those of you who read the documentation probably thought that you were just calling the QObject one. That's okay. So the ones that we are really using here are the meta object. This one. This is the good stuff. And we will use the cast operator and the meta call. Those are the fun things that we'll look at in the next few slides. But if you look at this, you see a few objects and you see some definitions of methods. And when you look at what comes out of a mock, when mock runs over your header file, there are these things are always there. Then you have your slots or your signals, and that adds more to what comes out of it. But these things are always there in the mock file. So, small QObject example. Brilliantly designed object here. Some object that has a count. So, what do we do with this? What does it say? Well, let's take a look at the definition of these things. QObject. That inserts these methods and objects that you just saw on the last page. QProperty doesn't do anything. It's empty. So this line doesn't really exist. Then you have the constructor, of course. You have a getter method. That's the getter for the count. This one. You have some slots. So this public slots here, since slots was empty, that means this doesn't exist either. So it actually just says public :void set count. And in here, in the count, you just check, did it really change? And if it did change, set it, and emit, I was changed. That's what all just random property setters do. And I can totally relate to Observer wanting to automate this. Now, of course, you can just say QProperty and you press tab, and Qt Creator will input most of this. You will right-click on it and say, implement the stuff for me. And it'll create the setter and the getter and the object, or the variable here for you. Don't abuse this. I heard of one company who writes this just to be able to right-click and do that filling. That seems wrong. But no, do it when it makes change. It makes something that really makes sense. So the signal here, this is the one that we don't do anything about, because this is what calls all the slots. So what is in the implementation of a signal? And when you think about it, well, those of you who have read the Gov book or in some other way have knowledge about patterns will know this is actually just a visitor pattern. It's that simple. They reinvented the visitor pattern, but in a way where we don't have to do all the stuff that you did yourself with Java in the 90s. Okay, moving on. Parent-child relationship. That's one of the biggest problems in C++ is crashes because objects were deleted, right? Anyone here who have never tried that? Good. I would have been surprised. So memory management is one of the things that especially people coming from garbage-collected languages always slam C++ developers with. We can't even do this. We have to do this manually. Then you add stuff like shared pointers to try and fix it, but you don't. You just create different problems. So Qt doesn't solve this, not in any way. But it does something that you can consider as a solution for some cases. It does present problems, but sometimes it's a solution. Whenever you delete an object, you also delete all the children. Most of you know this. This is baby knowledge for a Qt developer. So, yeah, there is not a lot more to say than that. You set the parent either with setParent or in the constructor usually. The find children is something that I don't know how many of you uses, but you can search a tree for objects that match certain parameters. It could be the object name, it could be a list of instances of a type, or something like that. Sometimes these tricks are nice to have. But for widgets, of course, you have the extra that a widget is placed inside the parent. So then it becomes not just about memory management, but also about how does the view stack up. Yeah, oh yeah. Don't ever put QObjects in smart pointers. Why is this? Because a smart pointer means, well, let's take the real discussion about this. What does it mean to have a shared pointer or something? Someone know that? Well, you know the answer that you're usually given. When you have an object in the smart pointer, then when all the instances of the smart pointer is gone, then your object is deleted. And you can have weak pointers and that, but that doesn't really change the picture. A shared pointer, when you don't have any more of them, you will delete the object. So why is that bad when it comes to this? Well, it's bad because of responsibility. That was the word I started out with very early. Because what are you doing with the shared pointer? Actually, you're saying no one has the responsibility of when an object is deleted. That's what you're saying, because you don't know. The only thing you know is when you don't have any more shared pointers, then it will be deleted. And if you ever have the cycle problem, then you won't be deleted, ever. So the only place where I allow anyone working with me or for me to use a shared pointer is when no one really has that responsibility. And sometimes that happens. If you have an object that really is self-contained, it lives to do a purpose, and it knows itself when it's done, and it's done when no one else knows about it. Then put it in a shared pointer. There are these free-floating objects that no one has the ownership over, or no one has the responsibility of deleting. Then I put it in a shared pointer as well. It's the only place where I ever use a shared pointer. But even then, you cannot do it with QObjects. And the reason is, if the parent of the object gets deleted, then your object inside your shared pointer gets deleted again. So what happens then? Your shared pointer object is later destroyed. It says, ooh, I want to delete that one. Double delete, boom. You cannot do it. Don't try. So QPointer was invented for this. This is basically a weak pointer. It's the only thing it does. There is one signal on QObject itself. Anyone know what it is? Destroyed, yes. I have been murdered. That's what it says. And QPointer uses this because it just connects to the object that you put inside a QPointer, so you know if it was deleted. That's what a weak pointer is, right? You can ask it, does my object exist or not? So that's where you can put your QObjects in instead. So that was a long discussion on that. Okay, QMetaObject. This is a beast that's defined. You can look at the definition of it inside the Qt definition or the documentation. And it's hilarious reading, of course. You'll spend your long winter nights laughing over this documentation. And what you'll see is, first of all, this is a value object. It does not inherit QObject. But it does have all the information you want to know about to do the dynamic method invocation. It knows about your signals, your slots, what the properties are. It knows how many constructors you have, and so on. So that's what you need to do all the magic. That's what you can, actually, you use the meta object to access the information built by mock. That's basically what it does. So there are a couple of examples here. My object, get the meta object, new instance, parent. This is how you can create an object. You don't have to call new button. You can say button class, give me your meta object, instantiate this one. So why write a factory method when we have one? Why use a factory method when you can just call new button? Well, sometimes we do read a JSON file that says, now you should instantiate the button to fill this. If you have a JSON file describing your UI, for example, then you don't know what comes. So you cannot write new button because it's described in the text file that you read at runtime. Then you can use this trick for stuff like that. And later down, you want to say the button should be red, or it should have the count 42. So this is where you call meta object, invoke method, my object. This is the method name, 42. This is one of the things you cannot do in C++ in any way without mock. A lot of people, when they talk about mock and say, why is mock bad? It's because they say, it's just because signals and slots, and you can implement signals and slots with templates. No, that's not the only thing it does. Stuff like this is not possible to do with templates. You cannot do it. So unless HubSpot actually does something over the next 10 years, then for now, we're stuck with mock to do stuff like this, not to do signals and slots. We could do those with just templates. But all of this stuff, that's the good things. Okay, so threads. Yes, that's a total. Now a context switch. We'll talk about something else. Seems like it, but it's not. Because what I'll talk about with threads is only for in the context of the QObject technology. So first of all, there is a long discussion on the Qt mailing list that has been going on since about 2003 on how to use QThread. You can use a worker object, you can subclass it, you can do the thread pool, stuff like that. And someone will say if you subclass it, you do it wrong. And whenever I see that on the mailing list, no, I'm actually not subscribed to the mailing list anymore. Sorry, I'm too much of a boss these days. Not in the new young speak boss name. I run the company, so I don't have the time for interest anymore. But you can find this in the archives of the mailing list, me saying no. If someone tells you you cannot subclass QThread, my simple answer is wrong. Of course you can. It solves a purpose sometimes, but it's dangerous, and you should only do it if you know what you're doing. The reason it's dangerous is because when you instantiate QThread, a few QThread object, to us, it feels like this object sort of lies between two threads, actually. You have your main thread over here, you say new, my QThread subclass, and then you call run on, start on it, and inside the start, then you'll start a new thread, and you'll have something running over here inside the run method of your subclass. But this code is in the new thread. The constructor, the destructor, and so on, they belong in the calling thread. So the object is shared between these two threads, and that's where it gets hairy. So if someone says, it's dangerous to subclass QThreads, and you shouldn't do it unless you know your reason for why you do that instead of using worker classes, then I'm happy. Then I agree. But saying, you're doing it wrong, and there is a very famous blog post on that, just called, you're doing it wrong, and that's just wrong. So the reason I'm talking about this QThread is that QThreads are owned by, or they belong to some threads. All threads live in all QObjects live in one thread. And maybe you saw Simon say, move to thread something. And that's the way you take an object and say, I really don't want this object to live in that thread. I want it to live in this thread. That's fine. What you don't ever, ever, ever do is in the constructor of your QThread subclass call move to thread this. Then you will have problems because now the destructor of the thread is running inside the thread you just created. So now your run is done, the thread is done, but your destructor wants to run in that thread, and things will go boom. So don't ever do that. I've seen it again and again. As soon as I see a code review and I see move to thread this, that's no. That gets me all, then I go find the hack axe and go all Viking on them. So just remember that. What does it mean to live in a thread? It actually only means one thing. It means when you have the connects between two QObjects, and these are living in different threads, then it automatically does a Qt connection between them. It's the only thing that it means. Nothing more than that. So if you do connect two objects from different threads, then you'll automatically get the Qt connection, because when your button emits something, then you cannot just call something that should live in another thread. Now you're going across thread boundaries. So you emit a signal, and Qt says, okay, I'll store the object on the event loop, and over in the other one's event loop. Then you'll get the signal, and now it will run the proper thread. So that means you need an event loop over here. Fortunately, the standard implementation run creates an event loop and runs it. It's the only thing it does. So things just work if you use a worker class, and that's why people usually say it's the right thing to do to not instantiate a QThread subclass, but just use it as a worker thread. Okay, enough threading. QML. I am also one of those guys who like QML. Some don't, some do. It's not as much as cubes. There are actually a bunch of us who likes QML. There are a bunch who do not like QML. So QML is, as I said yesterday in my QML script, I think the guy who invented QML came up with the idea of why is it that I have to do my signal, my slot, my setter, my getter, and my property declaration, and my connect all the time. Why can't I just write the property once and say how it should be calculated? That's what scripting languages do. That's what they're good at. So in my view, QML, the reason it was designed like it was originally was because we have been talking about this since the early days of QObject. Why can't I just script it? So someone did. Then it has the declarative language and so on, which is weird, but that's another thing. So the idea here is, how does this actually stack up with all the stuff that we saw from QObject? Well, first of all, this one here, the A, this is now a dynamic property on a QObject. Any QML object is something that inherits QObject. It actually inherits an item class from QML because it obviously has a bit more. But the properties here are just implemented as dynamic properties on QObject. So you can argue that, and there are optimizations around it and so on. But in the way you think about it, it's true. So these are, you have a dynamic property called A, and it's a Q variant that has the number 5 inside it. This is a Boolean, of course, blah, blah. And here you say this B is now, whenever flag is true, then the value of B is 42. When flag is wrong, or no, false is not wrong, then it is whatever is inside A at any given time to 117 times 117. So if the flag is false, then it says to this. Now A is updated. You set A to 20, and B is automatically set to 20 times 117. And the only thing this does is use all the signals and slots connections. It doesn't actually, but it uses the notification from signals. So you can think about it as scripting from your signals to slots. There's no reason to actually go into the details of how it really works. It's much simpler to just think about it that way. Think about this as a simple signal and slot situation. That's how I think about QML. I know it's actually implemented in a slightly different way, but it's all you have to do to think about it that way. So we also have a handler. So here you create a slot that's called onFlagChanged. Yeah, I'm sorry, you can't see. Do stuff. This is the JavaScript call. I'm sorry, I said it yesterday. I hate JavaScript. But it's what happens in here. So these properties here, every single property in QML has a handler that you can define. And that's called like that. OnFlagChanged, do stuff. Okay, so blah, blah, blah. Moving on. Architecture considerations. This is my last slide. So I'm actually right on time. Perfect. I told you they were boring, the slides, but I know you're reading it. So what I want you to do is stop creating spaghetti code. That's a simple goal, right? It's something we all want. No one wants spaghetti code. I don't know why spaghetti is so bad. I like spaghetti. I just don't like it in my code. Or code in my... One of the ways you do this, I cannot stop you from doing it, but I can help you to at least one of these. Try and make your QObject black boxes. That's really what it means. If you think about the way you were taught programming, all the way back to the first stage of your object-oriented ways of thinking, you were told, call methods on the object and then something happens inside here and then you return. No side effects outside of your object. That's basically the same I'm saying here. And I did teach object-oriented programming at university. There are actually a couple of my students here. So this is what I'm trying to do here. Use the signals and slots to do exactly this. Whenever you call a method inside an object, then something happens there. You modify the state of it sometimes. If you modify the state of it, sometimes you will want to call other things, because now you know when that happens, I want this and this and this to happen. But other times, the only thing you want to tell the word is, my state changed. I don't know what that means to the rest of the application. I'm just saying, then you can handle it. That's the idea of what signals and slots should really be used for. That's how you should use these things. So the last thing here, the last line, is actually how you do this. When you think about this, who is responsible for connecting a signal to a slot? That's the guy, the object, that owns these two, usually. Sure, plenty of exceptions. But generally, when you instantiate two objects in a place, that's the place where you know these should be connected with a signal and slot connection. So it's one of the guidelines that you can use in the place that owns the objects. That's where you do the connections. You don't create one and then create the other, and then you call this one and say, that's the guy you want to listen to. Now you're delegating responsibility all over your application. That leads to spaghetti code. Keep your responsibility one place. Know where that responsibility is. That's one of the things we can use QObject signals and slots for that we don't talk a lot about. And that's what we should talk a lot about, because that's really what will change your code from being bad to being slightly less bad, probably. The rest of the way, that's up to you. So that's all I have for now. Any questions? Question? How can you figure out the property event handler name of a QML object? Well, it's actually as simple as, I did have a slide about this, so the way it's this, oh, that was too long. No, stop, no. It's the name, it's called on, and then the name itself, and then chased at the end. And then it just changes, it uses camel casing, but it's always like that. On, name, changed. Okay, more questions? Yes?
You said that you shouldn't put a QObject inside of a smart pointer because of the double issue.
Yes.
Will the only exception be QPointer? What about QShared pointer, for example?
QShared pointers is exactly the same as a shared pointer. There is no difference. If the standard template library had been written 10 years earlier, there wouldn't be a Q shared pointer. There is no conceptual difference. There is a difference in the implementation, and I'm sure there are subtle differences. But conceptually, and the way you think about it, all the dangers and all the benefits of the object, the Q shared pointer is identical to the standard shared pointer. So the reasons for using that is exactly the same as what you would use with a standard shared pointer. So, nope. Nope. There is no magic. It is exactly the same as a shared pointer. So, no, you cannot use a Q object inside a Q shared pointer either. Yes? Scope pointer, no. That is one of the few examples of a smart pointer I actually do use with QObject sometimes. Because the scope pointer does not necessarily say that it will delete at the end, because you can take the object. But you have to be careful about scope pointers, because you can create a new QObject sometime and put it in a scope pointer, and I will do that. But if you then give it a parent, then you have to take it from the scope pointer. So it's up to you to remember that, and then you hire an intern and he will modify your code and it suddenly goes boom. So there are dangers, and the danger is not when you write it, because you're aware of it when you write the method, but maintainability of your code can be hurt when you do this, because in 10 years later, someone will modify that code and not have that danger in mind that you were thinking of when you wrote this. So at least make a note of it. Future self, future intern, there be dragons here. Yes, next one. Come on. I'm an expensive consultant. You're giving free consultancy. Come on. Yes. Yes, I can. Show the... Oh, it's there. It's not up there. The slide where we do the Lambda thingy. I can definitely do that. It's not often that I do Lambdas. I try not to do them too much. Oh, too long. There. But this is one of the things where I actually do like it. I also do it when I have to do queue timer zero time single slot. Yeah. You must be able to guarantee the lifetime of this. No, because there is this third argument that's called this. So if this is deleted, then this lambda doesn't get called. It actually checks that. You can do this connection with just reply and the finished and then the lambda. In that case, it will always get called. If you put an object in here and this object gets deleted, then your lambda doesn't get called. So leaks? No. No, it just, yeah, that's, but then you probably already have something deleting stuff. In this case, I don't think it would happen, but shh. I don't know. I think it's 10 years ago that I last had a question at one of these places where I had to admit, I don't know. I would have to check that. It usually doesn't happen when I do this, because whenever I do have something that calls network, then that object lives throughout the run of the application. So I don't have the problem. So it's sort of yeah, I've never tried that, but if I wanted to do that, then I would just test it. Then you know for sure you can handle it. Yeah, more questions? Come on, something that maybe not anything. Yes?
When is the object reply deleted?
When is the object deleted? When you call delete later. You don't know. And you don't care. The idea of calling, why should you call delete later? Well, there is one place where you always use delete later. And that is if you have a slot that's called, and inside, somewhere in the call tree of that slot, you want to delete the slot, the object that the slot is living in, the receiver object. If you do that, boom, you will crash. Not sometimes, anytime. So in that case, you use the delete later. There are other places like this one, anywhere. I'm not sure if this will delete something I'm working on at the moment, so I'll just call delete later. That's a bit too, to me. I don't want to know exactly when my stuff is deleted, but sometimes it's necessary to call delete later. What happens with that is that it creates an object to the event loop that's called an event, a delete event, and when the event loop gets to that object, then the object inside is deleted. That's basically it. That's why you don't know, because it could be an hour later. If your application suddenly wants to recalculate your database, then 2 hours later, the function comes back. Now you're ready to work on stuff in the event loop, and then your update gets deleted. Usually, of course, it will happen very quickly. If you do this with widgets, the trick is to call hide on it first, because then the user cannot see it anymore. And if you can't see it, it obviously doesn't exist. So I had 4 arms in the air suddenly. Alex? Yes. Now you are doing, you're talking about very advanced stuff. If you suddenly create an event loop after delete later, that is one of the places where delete later can actually fail. But most of the times, you do not create new event loops. Because that's dangerous. So unless you know what you're doing, don't create event loops. One of the places you do this is to make synchronous calls. If you want to make a call over the network and you want to have a synchronous call, says do stuff on the network, RPC to a server, for example. Then in there, you create you create a Q event loop, you send out your request, when this comes back, then you call quit on the event loop, you can return from the function. So modal dialogues is another reason you create event loops. Menus, sometimes you actually implement your own menu system, and then you also do this. Threads, another place. So there are places where you do it, but it's one of the more advanced cases. And you are really saying, I am done. So thank you very much for listening. Remember to put your business card in there so you can win the drone, so you can hack it. And thank you for coming.